Okay, I think we are now 3 p.m. sharp Manila time. So we will get started while people are still logging in, I see, but we'll get going with the introductions for now. So good morning, good afternoon, good evening, wherever you're joining us from. I'm Johanna Siliakus. I work for the Emerging Areas Transport Sector Office at the Asian Development Bank. And I would like to warmly welcome all of you to today's webinar. We have a very interesting session on e-vessels called Advancing Electric Water-Based Transport in Asia and the Pacific. So this webinar is organized under the umbrella of the e-mobility support and investment platform for Asia and the Pacific. This is an initiative for sharing knowledge and building capacities with the objective to support the scale-up of financing of e-mobility initiatives. And the platform is managed by the Asian Development Bank, the ADB, and co-financed by the Global Environment Facility, supported by UNEP and many other partners. The recording of this and other webinars we have organized in the past will be available on the platform's website. You can see the address to the website on the screen now, so emobilityplatform.asia. We'll also put that into the chat a bit later on. On that website, you'll also find information about other upcoming events. You can sign up to our mailing list, etc. Today's session will actually be the last session of this year in our webinar series, but we'll keep you up to date on upcoming webinars for 2026 in due course. And then shortly on house rules. To ensure a smooth session, we have muted your microphones. So all questions can be posted to our panelists or to our speakers through the Q&A function at the bottom of your screens. This webinar is recorded, and the recording, as I said, will be available on the platform's website. So today's webinar will provide a deep dive to pioneering initiatives in the field of electric water-based transport. There's a lot happening in this field, this emerging field. So we have a lot of exciting projects and pilots being developed. And you'll hear about some of those today. Now, let me hand over to our moderator for today, Bert Fabian. He's the Senior Transport Specialist at ADB, and he'll introduce the agenda and the speakers for you. Thank you. Over to you, Bert.
Thank you very much, Johanna. We have only 1 hour for today. I think we should have increased it because this topic of electric vessels, electric boats, electric ferries, it's always very interesting. And today we have 4 presenters. First is Biona Bycroft from NAUT and Ashton Shaw from Mackay. They will be introducing the NAUT case and the small-scale transport project in Samoa. Then we'll hear about the experience in Indonesia by Azura, and Nadia Nabila will be speaking on it. We will have Lou Tria from the University of the Philippines. They are piloting an electric ferry in Pasig River in Manila, in the Philippines. And then we will have Kunwan Swan Prinyawat from Mine Mobility Research, which is a subsidiary of Energy Absolute, who is running the electric ferries in Chao Phraya River in Bangkok. So quite a lot of agenda. So I will now turn over to NAUT, Fiona Bycroft. She is the co-founder and CEO of NAUT. And we will have Ashley Shaw, who is a project manager at Mackay. He's also an engineer and has worked on this electrification pilot together with NAUT. So without further ado, please, Fiona.
Thank you. So we're all here today to talk about electric vessels, and I'd like to start with my why, about why I'm excited to be here. So I went out on a charter boat earlier last year on a snorkeling trip, and it was amazing with the darting fish and the flowing seaweed. At the end of the day, we were taken into a sea cave, and there's filtered light and echoing sound, and it's magic. The skipper put the throttle down, and suddenly the cave filled with diesel fumes, and the sound drowned everything out. That moment of connection with nature was gone. And this is just one example in an enclosed space where the impacts of our marine activities are really felt. But this is happening everywhere, every day, all around the world, whether we see it or hear it or not. And there is a solution with electric vessels. So I'm really excited to be here today to share our part of that solution. Hello, I'm Fiona Bycroft, CEO and co-founder of Nought. But before I talk more about Nought, I'm going to take a step back to our sister company, Mackay. Mackay is a large electro-technology company that is based in New Zealand, but has delivered projects throughout Asia Pacific and beyond. They work in a range of fields and a range of services into those fields, but of particular interest today will be marine. So Mackay got into marine around 30 years ago, and more recently into electric propulsion around 10 years ago, when we supported the hybrid electrification of 3 research vessels in the USA. This then led to us doing the design and install for the electric propulsion system for the Wellington Electric Ferry. And that's been on the water for 4 years now. And then we were asked for advice about an electric outboard that would get a boat planing. Because there was nothing available that was powerful enough, we built one within Mackay. And this led to the realization that there was a gap in the market for this sort of product and that we could fill it. So Nought was set up to focus on these electric propulsion products. Since then, both companies have gone on to deliver more projects, and by the end of the year, we'll have 12 different vessels on the water around the world. So Mackay and Nought both do work in this electric propulsion space, with Nought really focusing on propulsion products, and Mackay as an integrator using Nought products where it suits. We both work very closely with naval architects and boat builders to ensure that the end user gets an electric vessel that suits their application. Because we've done a range of different vessels used in different ways, I'm going to cover off 3 very quickly. The first is Ikariri, which is a Wellington Electric Ferry. This is a 19-metre carbon fibre ferry that carries 130 passengers and operates at around 20 knots. The next one is Game Changer, which is an 8-metre speedboat. This is powered by Nought's outboard system. This vessel has a top speed of around 43 knots. And the last one is Ealia. And I'm really excited to hand this over to Ashley to talk through both the vessel itself and the project to deliver these into Samoa.
Hi everyone, I'm Ashley Owenshaw. I'm a chartered marine engineer and I've been with Mackay's now for coming up on 7 years. It's my honour to be the project manager for the Ealia build, and I'll be presenting the lessons learnt around this project, focusing on today on the end user consultation, local infrastructure, use of local industry, and why we believe early contractor involvement is so crucial. First of all, to cover off the project scope, so this is a 5-vessel build. They needed to have solar and EV charging. They needed to go 8 nautical miles at 6 knots on a single charge. But in actual fact, on delivery, we've delivered a range of 57 nautical miles on a single charge, and they can operate indefinitely without needing charge at speeds of 3 to 4.5 knots, dependent on what the sun is up to. The first boat we built in New Zealand, and then the 4 remaining boats we flat packed, prefabricated, and then we sent to Apia. In Apia, we worked with our local partners, Henry Silver Shipyards, a local Samoan company, and then we fabricated the remaining 4 boats in their yard with both their labour and our New Zealand tradesmen. The first boat went to Samoa Island, which you can see on the right-hand side of the page, and that's a village that operates a little tourist route out to Samoa Island, and that village maintains that as their tourist trade and income. On the other side, you'll see Manono Island and Manono Usa Wharf. So there are 4 villages on Manono Island, and each of those will receive one of these boats. And they'll use this mainly to transit between Manono Island and the mainland Manono Uta Wharf. They do school runs, shopping runs, and all that kind of activities. We also had to deliver a training package to the boat operators, make sure they could handle the boats. And next week, we're delivering the maintenance training package to 3 of the shipyards in Apia. We also need to deliver a 2-year maintenance contract with 6 monthly maintenance and in-service support through that time. What we do know is that these boats have the distance to be able to travel to Savaii Island, the other main island in Samoa. And there's also a little island between Manono and Savaii called Upper Lima, and they can travel to that too. And technically, with that 57 nautical mile range, they could, dependent on tide, swell, and wind, reach American Samoa, although they would need to charge before they come back. So end user consultation. Design succeeds when it reflects how the end user actually operates, not how we assume they do. So in regards to this project, we had very little to do with end user, with the end user. We dealt directly with our clients, and the access to the end user was really reduced. One of the items that came to the forefront early on was that we were required to deliver a boat that was cyclone resilient. But in actual fact, the villagers actually take the boats out of the water, and therefore they don't need to be cyclone resilient. So our boats are very sturdy, very structural, and also quite heavy, which means they can't be removed out of the water. And so in a cyclone, they will have to, the villagers will have to make sure that they anchor, fender, and secure these well, noting that these are operated inside the coral reef, and so cyclone effects are significantly reduced in those areas, but it is still a concern. Looking at the intended use and versus the actual use as well. So these boats fitted perfectly into the speeds that the current diesel operated Alia work. But we would argue that actually it would be better to have them go faster and have quicker transits between the islands as a benefit in delivering these as well. Also incorporating modern technology. So we incorporated steering wheels. Manono Island has no cars, and so this was a new concept for some of the villages, and we did have a good time getting out there, getting them used to the steering wheels. And that was a good incorporation of the technology. In regards to the VHF radios we gave them, all they'll be able to talk to is amongst themselves, as the VHF receivers don't really exist on the island. So there's little use for those in regards to that type of technology. Local infrastructure, I cannot reiterate enough how much a marine vessel build is a marine system build. You cannot build a boat irrespective of infrastructure. If you're doing a vessel, you need to make sure that it integrates with the existing infrastructure, or you need to develop that infrastructure to take your new vessel build. As you can see in this picture, we're quite high and dry. This was to secure and make sure we were fine to do the first lot of EV charging. So we did park this unnecessarily close. But you can see that embarkation for our boat, as well as the ones behind, are not set up to embark anyone with disabilities, small children, women who have trouble moving. And then also access to utilities. So we tried to offer a solar panel and micro BESS unit to go onto the wharf so that these boats could charge electrically from renewable energy when they're charging from ashore. This wasn't included in the contract, unfortunately, and so these power from the power grid in Samoa, which is unfortunately diesel generation. Local and regional industry. So sustainability cannot truly be achieved without using local businesses. And to be honest, as a project manager, working with our partners at Henry Silver Shipyard was one of the most enjoyable aspects of this project. They provided a direct access to the local network and businesses and small companies that operate in Samoa. So in Samoa, you don't have websites where you can look them up. They don't respond to emails, but what they will do is they will answer their personal cell phone. They will be at their office, and you can have a face-to-face conversation, and you can go, "Hey mate, I've got a job, are you keen?" And they will say yes. And that's accessing that network benefited Samoa and these local businesses. They were our boots on the ground. I couldn't be in Samoa 24/7, but Henry Silver Group operates in that space, and they were absolutely brilliant. They bridged the language barrier, and they bridged the cultural barriers as well. So even though Samoa and New Zealand does have a lot of similarities, there's still a few places where we had little glitches that they were able to explain. And just using that general local engagement was just, I really enjoyed. And also noting that sustainability really comes from when you have businesses that are operating in that space, you integrate a new technology, and then you try to fill that gap with those local businesses. Early contractor involvement. So noting those previous issues of the local infrastructure, local networks, we really feel that it is absolutely imperative that you use early contractor involvement. Every decision from design to delivery is shaped by supply chains, transport routes, infrastructure limitations, and resource availability. A build project in the Pacific is, I cannot reiterate, a logistics project. You need to use companies that operate in the Pacific, that are connected through the similar cultures and values, that live and breathe life in the remote Pacific. Understanding how parties communicate, whether it's via WhatsApp instead of formal software for maintenance reporting, whether it's just picking up the phone and calling, or face-to-face communication, knowing and understanding that is really important. Adapting and being flexible, having processes where you can pivot at a moment's notice, where in a developed nation, you might just be able to go get a different product off the shelf, but you can't do that in the Pacific. Understanding and being experienced in renewable marine infrastructure and logistics. So a company that's an example of what a successfully developed Pacific Island nation would look like. So in New Zealand, as well as in Samoa, large multinationals can't exist in our small remote countries. But a party of free companies working together can achieve a lot. And that is what we've done here. We've had free companies working together, Mackay the main contractor, and we've delivered these boats. Scalability and feasibility. So our EALI design is proven, it's scalable, and it's ready to be delivered to an island near you, or built in an island near you. We would additionally offer marine infrastructure, and we would really love to be a part of early contractor support, where we can deliver to people who aren't strong on marine or infrastructure or renewables or working in the remote environment of the Pacific. We can provide that knowledge, and we can provide it with passion. And then lastly, obviously, just the additional aspects where we can very easily, with our base foundation, incorporate different uses, different aesthetics, and obviously the faster boat as well. So that's our presentation. Thank you for listening. And if you need to contact us, here are our QR codes. Thank you very much.
Excellent, Ashley and Fiona. This is very good. And you also mentioned many of the word resilience. Like this webinar also focuses on the archipelagic countries, the Pacific, which is where there is need for, or possibility of need for, these electric vessels. And you also mentioned about logistics, local content. I assume this is also because our colleagues from UNDP is supporting this project and has also put in place also many of these sustainability issues. Thanks again. Let's go now to Indonesia. Our guest from Nadea Nabila, the founder of Azura, and we will hear about her experience in piloting electric boats in Indonesia. I hand over to you, Nadea. Thank you.
Thank you, Bert. Good morning, good afternoon, and good evening, everyone. Next slide. So before I start sharing about this project, I want to tell you a little bit why I do what I did. So once upon a time, I was an electric engineering student back in South Korea, and then I moved back to Indonesia and become junior project manager, help financial service industry to deliver the digital system. And from there, from student to become a corporate employee, there's a lot of gap, and to maintain the sanity in myself. Next slide. I spend a lot of time to do diving, both of scuba diving and also free diving. From that activity, actually, I gain a lot of insight from the small scale fishermen that helped me to fulfill my needs of fun diving. So now, next slide. So now what I did is trying to help them, small scale fishermen, to be more resilient in this climate change transition. Next slide. As you know, Indonesia is the biggest archipelago country in the world. We have more than 15,000 islands. And with that geographic, Indonesia have over 2.7 small-scale fishermen. Next slide. Where 48% of them still lives below the poverty line. In my personal opinion, this happened because, next slide, please. This happened because small-scale fisher, they have limitation. But before jump to that, I want to make sure that all of us have exact same understanding about small-scale fishermen. Small-scale fishermen that I will continuously saying in the rest of the presentation is this typical of coastal community or fishermen. They are using small boat. They are using small fishing gear, so they are not going too far from the coastal. Roughly maybe around 5 kilometers from the coastal. Next slide. Next. So back to the reason, in my point of view, why there are 48% of them still live below the poverty line. What I gain from the field is they are getting hard to get the gasoline. Now, what happened? They are really depending on the gasoline to do fishing. And the second one is a long supply chain where it is isolate them to have direct market to sell their catch. And the third is access to credit to the finance. Why? Most of the small scale fishermen, they are unbanked, even though they have an asset, but they don't have any history in conventional bank. So it's make them hard to get financial access to credit. Next. This is what happened about the gasoline problem. Because when the gasoline is really scarce, they are really hard to get the gasoline. Once the gasoline is available, it's also eating them up from the inside. Roughly, most of the fishermen, my point of view is small-scale fishermen, they spend more than over 60% of their income only to buy fossil fuel. To remember that their operational window 1 year is not 12 months. They only have 9 months to do the fishing due to the low season and bad weather. With 9 months operation window, the approximately monthly income is only roughly $3.350 with annual earning. You can do simple math by yourself, 3,150. Next. So there is one time, I think 2018, when I come back to Indonesia after finish my master degree, I dive in one of the dive spot in Bali, and there is manta passing by, gliding above my head, and that's actually become the turning point to do what I did today. Next slide. In 2020, right when COVID hit, I established social enterprise called Azura Indonesia because I want to contribute to make a clean and sustainable for Indonesia. What we are doing is actually trying to provide green technology that accessible to everyone. Start with coastal community. Next. We come up with this solution of long tail shaft electric version in 2018 to 19. Our target still small scale fisher to empower them because they cannot be prosper, they cannot have better livelihood if the operational is still eating them. So we come up with this. I called this solution or our flagship product is Mantawan. Next. specification of Mantawan. Mantawan is equal with 5 horsepower engine, is small, is mounting on the side, and it's really fit for boat not more than 5 gross tonnage. The Mantawan itself powered by a battery pack, where the battery pack, if you surcharge it full and use it, it can hold up until 4 hours at a maximum speed. So far, the maximum speed we can reach is 5 knots, 11 kilometers per hour. Next. Next slide. Okay, the unique selling point of Mantawan is when the user shifting from combustion engine to Mantawan, they can create 2 direct impact. The first one is carbon footprint reduction by 78%. It can go up to 100% and create closed loop of renewable energy if the user charge the engine battery using renewable energy sources. And the second one of direct impact is cost per trip. When user shifting from combustion engine to Mantawan, they can reduce right away 70% of the cost per trip. We get this presentation by calculating as well purchasing price, power price, and battery amortization. Next. This is just an example how big the boat is and the usage of the fishermen to do wild catch on the open sea. Next. So currently we offer 2 versions of Mantawan. The first version where we are using our configuration of battery pack. So inside this battery pack luggage, it is our configuration that can hold up until 4 hours continuously at maximum speed. And next. Also, we're trying to integrate with a battery for another EV, a 2-wheeler EV. So for in Indonesia now, it's really common to do the swappable battery for 2-wheeler EV. And we're trying to integrate the technology as well and be more adaptive with the technology that's available in the market. Next. Since 2020, we already sold several units, and it's been operated in 7 locations in Indonesia across the island. And there is one international location in Fiji Island when we do piloting back in 2023. Next. Yeah, we're still a small startup, social enterprise as well. We have product team and program team. Next slide. If anyone of you interested to talk more, let's connect on our LinkedIn and we can set some discussion later on. Thank you.
Thank you very much, Nadea. That is very interesting. And also the use of this, the batteries for the electric 2-wheelers. I'm sure it's quite widespread in Indonesia as well as is similar to other Southeast Asian countries. There are questions that we are receiving from the audience. And for our previous presenters, Fiona and Ashley, please look at them. You can also answer them or type your answer. But also maybe we'll have an opportunity for you to look at this and reply. But for you, Nadea, maybe it will be similar questions with respect to the cost. For our audience, many of these are at the piloting stage. So I'm sure in terms of cost comparison with the traditional crafts, OPEX and CAPEX, maybe there is a wide difference. But thanks again, Nadea. Let's go first to the next presenter, and then we can probably open for question and answer as well. Next presenter is Lutria. He's a professor at the Electrical and Electronics Engineering Institute of the University of the Philippines in Diliman. And they are the ones who have, I believe, piloted the electric ferry last week only in Pasig River. This is a 25-kilometer, 30-kilometer river that cuts across Manila. So I hand over to you, Professor Tria.
Hi, good day, everyone. I hope you can see the slides.
Professor Trier, we see it in the presentation mode now. Sorry, in
Okay.
the back side of it, so not the slides.
How about now?
Yes, now it's good. Thank you.
Okay. So yeah, so thank you very much for Asian Development Bank for giving us this platform to introduce our project on developing a sustainable water transportation in the Philippines. So I will go through these points during my presentation. Okay, so the rising cost of fossil fuels are also increasing the demand for sustainable transportation, particularly in the marine sector. In the Philippines, the transportation sector is responsible for 13% of greenhouse gas emissions, and marine transportation alone accounts for 8% of this 13%. And this sector is often overlooked when it comes to electrification. The current electric vehicle industry roadmap of the Philippines, okay, we have a comprehensive roadmap for electric vehicles. Unfortunately, does not include goals for the marine electric vehicles in the short, medium, or long term. So this oversight is concerning, especially considering that the International Maritime Organization, or IMO, has already uh, intended to have a net zero by 2050. One way to achieve cleaner transportation is through electrification of the sector, and passenger ferries are prime candidates for this shift due to shorter, consistent routes of the smaller vessel size, relatively smaller vessel size, and simplified access to shore power and charging points. In the Philippines, numerous river systems rely on passenger ferries, which play a crucial role in various applications, including tourism and transportation. One notable system is the Pasig River Ferry system, located at the heart of five major cities in the National Capital Region. Based on surveys and data collection, the following operational characteristics have been identified for this ferry system. So the operation hours is 12 hours. The average round trip distance is 30 kilometers with a maximum distance of 45 kilometers. The round trip duration is 2 to 3 hours. There is the docking time at respective stations of 30 to 45 minutes. The fleet size currently is just 7 ferries, each with a capacity of 55 passenger. This river system also has a unique characteristic that it has quite a very shallow water with a minimum of 1 meter and a low height clearance due to the presence of bridges at different points of the river system. We had a project before where we developed a methodology through our Department of Science and Technology to evaluate the techno-economic feasibility of various electric configurations. So, using life cycle cost analysis, the study found that a fleet employing a battery electric configuration resulted in the lowest energy demand, energy cost, and total cost of ownership. While previous research also indicated that retrofitting a ferry to be fully battery electric is the most advantageous in terms of operations and total cost of ownership, we found out that there's still potential for optimizing the design improvement to enhance feasibility for this mode of transportation. So the improvement also of the local shipbuilding industry is particularly relevant to the Philippines, as our country ranks fifth among the top shipbuilding countries in the world alongside China, South Korea, Japan, and the United States. Okay, the next step toward achieving a more efficient marine transportation system is the ground-up development of an electrically propelled vessel. So the previous slide showed all the motivations behind the electric project funded by the Department of Science and Technology in partnership with the Metropolitan Manila Development Authority and implemented by the University of the Philippines, Diliman. We proudly present the Philippines' first locally designed and developed battery electric passenger ferry named MB Dalaray, motorboat Dalaray, a fitting name for a vessel that embodies the flow of current. So the MB Dalaray is designed for battery electric operations and targeted to be deployed at the Pasig River ferry system. And it has the following features. So it has a catamaran hull design, 30 meters in length, 5.2 meters width, and 0.7 meter draft. It is constructed with marine-grade aluminum for strength and corrosion resistance. Twin 50 kilowatt electric outboard motors were used. The battery is 160 kilowatt hours lithium ion battery. It is capable to travel for 45 kilometers at a cruising speed of 8 knots. There are 3 charging points along the river system, and the passenger capacity is 40 passengers with or 5 tons of load. It is equipped with digital control system, quiet DC motor with zero direct emission, and makes use of renewable energy to achieve higher efficiency. So the project has these following objectives. First is to design the appropriate specifications for the case study of the Pasig River ferry system. Second is to execute the fabrication through industry experts. Third is to integrate the electrical propulsion to the structural elements. And finally, to pilot test and deploy the vessel as part of the operations. The project has 3 phases over 2 years of implementation. First phase is mainly includes the design of both structural and electrical propulsion. Second phase is the execution and fabrication, electric propulsion design, and charging station deployment. Finally, the last phase is the integration and pilot deployment of the developed ferry. The design involves also optimizing the hull design by considering its structural shape and performance regarding total resistance and powering requirements. Our objective is to evaluate these different shapes to minimize the expected resistance and consequently the powering requirement. By optimizing the structural design, we can reduce the required battery capacity and motor rating for this prototype. The auxiliary loads are powered by purely renewable energy. The second phase include the actual ferry fabrication, employing the local shipbuilding industry and working with different relevant agencies such as the Society of Naval Architects and Marine Engineers of the Philippines and our regulatory body for water vessels, Marina, to ensure that the design and execution are up to standard to promote safety and reliability of the vessel. There are also 3 charging stations that we determined along this route where we set up the charging system. So the final phase of the project focused on the integration and the actual deployment of the ferry. Some show you some preliminary results. First on the technical ones. For preliminary testing, the ferry undertook initial testing with different loading conditions. So we compared the simulated energy economy with the actual loading condition, showing that the actual energy economy deviates somehow with the simulated, but at least the trend is can be seen here. We attribute this deviation to environmental conditions such as debris in the river, the speed of the river flow, which we have not included in the original one. So we are recalibrating our models to be close to the actual performance. The solar system also was able to cater to the demand of the hotel loads during this testing with a maximum production of 15 kilowatt hours, averaging at 6 kilowatt hours. Producing the most of the load, okay, and the remaining are stored in a battery system, a separate battery system dedicated for the solar power. We also had initial onboarding of 43 respondents, passengers, uh, and this shows quick demographics of the respondent in terms of the frequency of their use of the Pasig River Ferry and frequency of using public transportation. The respondents were also able to give feedback on the different aspects of the ferry, using 1 being the lowest rating and 5 being the highest. Listed here are the clear positives based on the first set of passengers to use this ferry. On the economic side, we did an initial comparison of the existing diesel passenger ferry with the developed electric ferry, considering 20 years of service life. In terms of capital cost, as expected, the electric ferry has significant higher costs due to the propulsion system and the charging system. However, it should be noted that this is only a prototype cost, and these are expected to be more competitive once the production increases. In terms of operation and maintenance, the energy costs associated with the diesel ferry are higher due to the increasing diesel prices. For the electric ferry, the cost of battery replacement contributed to the maintenance expenses. However, even when factoring in battery replacement, the overall cost of the diesel ferry remains significantly higher than those of the electric ferry. A simple comparison reveals that the cost per kilometer for diesel operations is nearly 3 times greater than that of electric operations. And this is based on the energy efficiency of both vessels. We also look at GHG emissions to reflect the environmental effect of each configuration. We used the estimation, use in the estimation are diesel fuel and electricity grid emission factors based on estimates of ADB, and the annual cost per kilogram of carbon dioxide are based on the estimates of EPA, or Environmental Protection Agency. Moving forward, we have successfully launched the ferry last October 6 at the Pasig River in Manila. And you should be able to see the featured videos and news in various news outlets. We are also scheduled to integrate MB Dalaray to the Pasig River Ferry Service starting this Monday, November 17. So it will be open to the public on Monday. And we invite the public to experience this sustainable mode of transportation. I invite everyone to check the voyage schedule through our Facebook page. With that, I end my presentation. Thank you very much for your attention. You may contact us through our contact details shown here. Thank you very much.
Thank you very much, Professor Treya. That is very promising. All the best to you and your team. It is surprising to see that the life cycle cost assessment is already lower for the electric ferry. Of course, the challenge would still be the capital cost. But anyway, please stay online, and I hope we have a bit more time to answer some of these questions. But I would like to go now to our presenter from Energy Absolute, Kunwan Swad Prinyawati, is the Vice President of Mine Mobility Research, a subsidiary of Energy Absolute. Now, this company has been running electric ferries in Chao Phraya for quite some time. And I believe they'll be able to share with us more information in terms of their experience. Kunwan Swad, please kindly focus your presentation on the electric commuter ferries so that you can have more time to explain them. Thank you very much.
Thank you, everyone. Can you see our screen? Hi, everybody. Thank you for letting us explaining what we have done for the electrical ferry fleet that we have done so far. Okay. Bert, can you see on my screen?
Yes.
I can see your screen.
Yes.
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 Thank you, everybody. Okay, what we have done in the last 5 years is original from the EA business that I can explain in background so that you can see the. Okay, Energy Absolute has the business on renewable energy in the past. We starting from the solar farm, wind farm, and waste energy plant, and then we have the EV ecosystem that can enhance the EV application, starting from the battery plant, Amita technology, and the charging business, energy hackathon, and also the commercial EV plant, AAB. The timeline of this business that we have done, we start from about 2010, and then on 2016, we set up the Mine Mobility Corporation and Mine Mobility Research that do the EV business. Also on 2018, Amita Technology Thailand has been established. And on 2020, we launched My Smart Ferry, the first electric ferry service in Chao Phraya, Europe. The key success that made us success on the EV ecosystem is that we have the fast charging battery that's produced by our own Amita factory, and also we have the charger or charging business across the country, and also we have the plant that can fabricate the bus and the truck by ourselves. That this is the overview of the Amita plant. That the capacity is about 1 gigawatt hour. We can do the fast charging with this battery up to 3,000 cycles. And also we have the technical and business support from the BOI, so we can get the benefit from the free zone tax exemption, and also the expansion in the business by supporting government. This is the overview of the fast charging, how it looks like. It's the station that can serve the bus or the EV. And now we already installed more than 500 locations countrywide, and that's count on about 2,000 charger heads. This is the overview of the AAB plant that can fabricate the passenger bus of up to 12 meters, and also the tractor head. This is the tractor head that we assembly in this plant. So the EV product that we produce so far comprise of 5 categories, starting from the mine truck, and this is EV tractor head. The battery size about 300 kilowatt hours, and then the mine bus, the passenger bus of about 11 to 12 meter, and the locomotive that is fit with our Amita batteries. The MAN MT30 is a 1-ton truck, and the MAN Smart Ferry that we are going in detail later. This is the tractor head pictures that it looks like. Now it's more than 1,000 units in operation. Each tractor head fit with about 300 kilowatt hours battery and can go to more than 200 kilometers per charge. This is the passenger buses that we already produced more than 4,000 units, and about 2,000 units are already operate in that area. This is the locomotive that we put the battery for serving short range cargo transportation. We are working with State Railway of Thailand at the moment. The first prototype already launched, and now we are upgrading and developing on the second units. Each locomotive fit with 4.1 megawatt hour batteries and can go to about 300 kilometers. This is 1-ton battery EV mini truck that is already launching commercially the last few years. It is fully assembled in our plant in Thailand. So let's come to the ferry part. The first generation we already designed and also launched and put in service of operation already. It's the 24 meters catamaran style, built with aluminum alloy and equipped with about 800 kilowatt hours battery that can serve the speed about 15 knots, but we go cruising about 11 to 12 knots. So it can go to 80 to 100 kilometers per one charge. And the charging time with the fast charge technology, we can do within 20 minutes. The passengers capacity can go up to 250 passengers. So now this first generation already launched for 26 ferries already in operation from 2020. The route distance is about 25 kilometers, and the running time or travel times for 1 hour or one something up to that we go upstream or downstream. This is the interior of the passenger areas. So you can notice that there are several arrangements, like all passenger seats face forward or can face on the side as the same style of the BTS or subway. Also, we have the few of the first generation convert to a tourism version. It's called a double deck version, so that the passengers can go upstairs, enjoy the open air, and also have the toilets or the WC on the lower deck. So last 3 years, we also developed to the second generation design. This one a little bit smaller, can pass the bridge easier by lowering the aircraft, and also can go a bit the same size or the same speed. It's about 15 knots, and the battery is about 720 kilowatt hour. The charging time also the same. It can go within 15 to 20 minutes. And the passengers become 150 passengers, because the break of the vessel is a bit narrower, from 77 meters to down to 6 meters. But this gives more handleability with the maneuvering and going under the bridge easily. Now already 14 ferries of this design already launched and put in service from last 2 years. Yeah, same like the first design is fully air conditioning cabin, and the passenger capacity 150. This house already developed by considering the weight wash, so that we reduce the weight wash by nearly half using the newer hull form, and the air draft already lower by nearly 1 meters. So it's more usability is easily for the operator all year round. This is the interior of this second generation design. They can arrange the seat or facing forward or facing as each tables for the tour version, or on the side like the BTS style also. So it can be arranged easily. This is the overview of the control console. Everything can be monitored and controlled by the steering man with the CCTV all around the vessels, nearly 14 or 15 cameras, all real-time monitor and recorded. Also, we have the fire control panel that can monitor all the fire sensors, smoke detector, and also we put automatic fire extinguisher in every battery pack, so that it can be operated automatically in case of there is thermal runaway. So already 14 ferries of the second generation in service every day in Chapaya River, and also have some commercial advertising that give a colorful touch to the profile of this design, as you can see. This showing the route of this ferry fleet, starting from the north or the southern of the Bangkok, before Phanangkao and Nonthaburi, and down to the heart of the Bangkok city through the Royal Palace and Wat Arun, or Temple of Dawn, the iconic landmark of Thailand, and also down to Icon Siam, the best department store in Thailand, and down to Sathon Beach, where the passengers can go to BTS or the mode of transport like the bus or the BTS. So it's along this route there are more than 20 piers along. They serve all the commuters from northern part of Bangkok to work in Bangkok every day. So in total, this fleet is about more than 40 ferries already operation in Chapaya River since 2020, serving more commuters and tourists 7 days a week, 52 weeks a year, and with a fully air-conditioned cabin. Now the passenger ridership is now about 30,000 passengers daily. There are 3 service lines with the longest distance of about 25 kilometers with about 1 hour traveling time. But come down to the charging station that is very crucial for the electric ferries. We have the patent multi-fast charge technology that many chargers can charge in the same time to one single vehicle. That is our own patent technology. So this is the first charging station that we developed for our R&D activity. It's installed 14.
Swan.
Yes.
I think your photo has frozen.
Yes. So, okay. So for 14 platforms, we also already installed in this chargers. So about 3.2 megawatt hours power. And this is the operation of the charger operation about 4 stations to south end and north end. Every charger equipped with patent multi-fast charge technology. And this is our service team that can do all the service with the high volt battery, electrical control, structures, mechanical, everything we can do our own. With our floating docks can serve the underwater work also. So that is all the things that we can do with every product that we can serve starting from the bus, the truck, train, and the ferries. This is just for the pleasure to serve our future generations for the cleaner, better world. So it's synchronized with our energy absolute motto, energy absolute, energy for the future. Thank you. Yes.
Thank you very much, Kun Swanswad. I think it's very good to see how extensive the EV ecosystem, the investments of Energy Absolute, and your experience with the electric ferries. I didn't even realize that you already had the second generation. Maybe in the mind of our listeners, they are asking about the profitability of the electric ferries or the financial viability of well, what is your experience so far? But I assume it's you're expanding it, so I assume you're making money. And also one thing I would like to highlight, which has not been highlighted by many, is the impact of these electric vessels on air quality, especially in the cities, because many of these electric vessels are using ICE, internal combustion engines, and they also contribute to air pollution. So maybe this is something to factor in also for. But yeah, very briefly, Kun Wanswat.
Yes. Yes, for sure. The you saw the infrastructure business is quite difficult to earn good money, but we try to control everything in the good pace. And I heard that from the operator that the EBITDA is okay because we let's say they operate not only the ferry, they operate the electric bus also, and that is also the bigger picture. What I heard from the executive is that the EBITDA is still positive. So it's a good news that we still can go on with this huge investment, as we may know. And also we also have the the tractor head as our new product that we believe that it will leverage our investment further because the EV uh, uh, popularity in Thailand is, I think, is much better than the last 4 or 5 years. So I think the electrification of the vehicle, both in land or on the water, is a good feature. Not so any problem. We think this much better for this business to go on. And also for the air quality, yes, for sure, it can simply compare because we still have a diesel, I mean the diesel engine ferries with another operator still operate, and passengers can compare easily when the EV ferries come to the dock and the diesel engine ferry come to the dock. It can notice easily with the noise and fume and the smell. Yeah, I think the EV ferry is much obvious better. Yes, in that sense.
Thank you
Thank
very
you.
much, Kun Wanswat. We
Yes.
don't have a lot of time, but I wanted to
Yeah.
give the chance to Fiona, Lou, and Nadea. What do you need? Like, we know that there are advantages and disadvantages, particularly in the capital cost and the piloting. But what do you think? What is needed in your areas, in your countries, to build more of these vehicles, e-vessels, or mainstream it? Let's start first with Fiona, and then Nadea and Lou. Fiona.
Well, my view is that the technology is ready to go and it's been proven. It's certainly finding the right applications that do, if it's being done for financial reasons, there's plenty of applications that will get a return on investment. So it's just finding those companies or situations, and sometimes some of them just need some help getting over that upfront capital costs so that they can get the long-term financial benefits and the immediate non-financial benefits from going electric. But certainly from our side, it's not the infrastructure, it's not the technology with our solution that's getting in the way.
Thank you. It's the financing. Nadea, what about for you? What do you need?
Thank you, Bert. I have a quiet pointer here. The first one is of course access to affordable financing, because most of the small scale fishers cannot afford upfront costs for an EV engine, even with lower operational expenses. So we need blended finance or a micro leasing scheme through cooperative or local banks or development partners. Second is a charging and service infrastructure, establishing coastal charging station powered by renewable and training local technician. So that second pointer is quite challenging. And the third one is also policy support and incentive. So government incentive for electric marine transport or similar to land EV. That's from me.
Very good, Nadea. Professor Lu.
Yeah, sorry. There's a train passing by. It takes time. It might be so noisy. But yeah, financing is also an issue because of to hurdle the capital cost. But I think I agree with Fiona to look at for now, the non-financial benefits, maybe put a value on it for the emission. So I believe there are green financing available that can be tapped by the industry. I think one of the issues is really to get an industry adapter or an operator of this system.
Thank you very much, Professor Lu. I will hand over back to Johanna. We in ADB, we're going to have a regional workshop actually that will look at financing of electric mobility for mainstreaming e-mobility in Asia Pacific. It will be in the first week of December. It's not really open. I mean, we are funding a few countries, government officials to participate, some private sector. That's really to exchange this kind of interest. Unfortunately, there is no specific focus on specific modes of transport. It will be a mix. But I would like to thank now Energy Absolute because they are actually hosting us for the study tour to look at the electric ferries, the electric trucks, the electric buses. But I stop here. We will have more opportunities later on and also next year to look at this issue of electrification of vessels. Thank you very much to all our speakers. Johanna, I hand over back to you.
Yes, well, from my side as well, thank you so much to all our speakers. Really valuable insights to all our participants as well for staying on. Apologies for going a bit over time. There was a lot of information and interesting topics to go through today. This was the last webinar for this year. We will be posting the recording on the website. So I posted it on the chat as well. You can find it at emobilityplatform.asia, typing it into your browser. So thanks everyone. Without further ado, I guess we'll close for today. Thanks. Take care. Bye.
Thanks everyone. Bye.